All right, we're finally done with chapter 2.1, Principles of Network Applications. Well, we did spend a lot of time there, but it's kind of important. I would rather like that we take it slow and make sure that all these basic notions and terms, concepts are all clear. Okay, so take note. We did talk about, hey, there's architectural choices. There is also transport layer service choice. And there's also definitions of messages being sent. So how many types? And for each type, what is the syntax and what is the semantics? And then hey, different types of messages might be, exchanged one after another. What is the order of these messages being exchanged? In fact, from chapter 2.2 and on, okay, all the way to 2.6, we'll be talking about examples of these applications and the corresponding application layer protocols. In these application layer protocols, you will hear me saying again and again, what is the architecture choice? What is the transport layer choice? What are the messages, formats, ordering of the messages being defined? Now, in each of these applications, you might hear, especially those that are frequently used and very important ones, I'm going to talk more about how you try to improve the performance, okay, of running these services. So let's go ahead and start the first application, web and HTTP. Let's do a quick review. Web is essentially a bunch of these web pages interconnected. So each web page consists of a number of objects. The base object is typically a HTML file. And then in each file embedded are several referenced objects. And these objects could be another HTML file, could be a JPEG image, could be an applet or a script or an audio file. Each object on the internet, on the web, is addressed by the URL. So this is an example of the URL. There are three parts: the host name, and the path, and the file name. Okay. And the HTTP protocol there to support the web application runs in the client-server model. So the client here are essentially the browsers. The browsers is essentially requesting for web objects and then in turn receiving web objects, of course, using the HTTP protocol. Now another task the browser does is displaying the web objects. Just to clarify, passing of these messages and web object is the HTTP protocol's job, but displaying web object is actually something else's job. It's the HTML interpreter's job. Yeah, so HTML interpreter is not quite the HTTP protocol. So you see here, a browser, that program there is a combination of the HTTP protocol client side and an HTML interpreter. So this interpreter is to interpret the HTML page because there are some markups around. Based on the markup, the interpreter will know how to display a web object so that it appears properly and nicely. Now the server, web server. Very few of you guys have experience building your web server, I suppose. Yeah, so in this example, we see Apache, I think, is still the most used server, but this guy here is catching up, Nginx. Both of these servers are implemented using C and C++ socket. All right, so the web server implements server side of the HTTP protocol. So what it does is to receive requests and send back response. So that's the exact opposite of the client. It's to receive objects and send request. So let's see the exchange. So this client up here, sending HTTP request and then receiving the HTTP response, and containing the HTTP response is the web object. Similarly, if it's a phone, Safari sending HTTP request and server sends back an object and Safari renders and displays the object. All right, so that's HTTP, Hypertext Transfer Protocol, HTTP. And HTTP runs on top of this transport layer protocol, TCP. And the whole process is actually this. First, tries to establish a TCP connection between the web server and the web client, and then sends the HTTP messages. So before the client and the server sends HTTP messages, the client and the server sends TCP messages first. So starting from the client, initiating a TCP connection. Now, if this is a web server sitting on the default port, it's going to be port 80. And then server would accept the TCP connection, inform the client, and then client can begin sending the HTTP request. And the server sends back HTTP response. When everything is done, the TCP connection will be closed. Know that HTTP, as you see, very simple, request response. In fact, each of these requests is treated as brand new, it's very fresh. That means what the server is doing there is to not record anything about the client. So there's no information about the past client requests. Okay? And we call this type of a service a stateless service. So on the server side, there's no requirement of storing anything about the client. This is really nice because the server does not require a lot of memory space for these information. All right. Protocols that maintain states can be complex. So this is the other extreme. You might need to maintain the past history, which can be long. And you might need to maintain history for multiple clients. How about that? That's a lot of burden in terms of a memory space requirement. And besides the service load, the memory requirement, what if the server and client each crash while the other continues to run? Then the states on the two sides might be inconsistent, and they will have to resolve the conflict somehow. That's the worst, right? So should you trust the client or should you trust the server? This is one of the classic car problems, all right?